Hey y'all, this is the fourth video, and we're working on procedural meshes. And yeah, in the tutorial section, you could see the other two videos, starting from the triangle, the quad, the cube, and now we're gonna make a chunk of cubes in this video. And if you want to pick up from where we left off from the cube mesh to follow along, just grab the package right here, and then you'll be able to pick up right here where we are now. So what I did was I added another floor because so far this is the triangle, the quad, and the cube here that are going to display. Do they display? They should display. Let's check. Yeah, it's those guys. And now back here, I just want to make a huge chunk of cubes. Okay, so let's see. Let's add an empty game object just to mark the location of our chunk cube. And let's see, just reset. And it's there. And oh, let me add a visual. What color should I use? I'll use green. That's a new color. And we're going to call this the cube mesh. No, the chunk mesh. Little by little, we're making our way up to something bigger. All right, and I'll just move the chunk mesh. I just want it to be like here. So that is going to be a -1. It looks like it'll be a -1 and a 2. Yeah, so it starts right there on the corner. And hold on. All right, so we have the chunk mesh. It's going to be this. It's going to start. This is going to be its origin point, and the chunk is going to go out from that point in those directions that the arrows are actually pointing. So here we're going to have to add a script like we did for the other things. But this script is going to create a chunk. So let's call it chunk mesh. Chunk mesh. And let's open it up. And let's just do my preliminary scrappy-doo. And let's see. Now we've already done the basics before, so let's copy from our cube mesh script and continue. All right, so I'm gonna have to make this full screen here. And let me split the windows. Windows split. Okay, so we could have the cube one here and our new chunk one here. Now we know some things are gonna be the same, like we're still gonna use the new quads and the points, okay, to make one cube. So I'm gonna copy that. That's gonna be the same. All right, so what this was just saying that a cube has 6 sides, and this is an enum to describe each side, and the sides were described using points. And then the points, this is just a static class, so I could refer to each of the points by a variable from this class instead of having to re-specify vector, 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 vector. And yeah, this is the little graph that helps us understand the points of one cube. And we'll put that here too. Just copy that. So far it's easy. So far we're just copying. And I have an extra curly brace. All right. And we're going to have these arrays as well. So let's copy that. Now here's our first difference is we won't know how big the chunk is going to be. We're going to let the user tell us how big the chunk is going to be. So these arrays here, we're not going to define them in the thing. All right, so we'll just say no for the sizes here. We're not going to allocate the arrays when we declare them. We're just going to declare the variables here. And we're going to let the user tell us how big to make the chunk. So we're going to give it a public a vector 3 is good because it has 3 values, one for the x, y, and z, and we'll say how many cubes, okay? So new vector 3. That way the user could tell us how big they want the chunk to be, how many cubes in the x, y, and z direction. And then therefore that changes up our start function a little bit. So in the start, private void start, we are going to have to allocate first the arrays, excuse me, to hold our data, and then we could do the define mesh data stuff. Okay, so I'll copy that. Now there's squigglies, yeah, because I didn't type the function yet. All right, so that's the same. So let's do the allocate arrays function. And you know what? Let me just comment these out. They're not ready yet. So we're going to make an allocate arrays function. And we're going to have to know how big these arrays are going to be to make the chunk the user's requesting. Private void allocate arrays. All right. And we have to think about this. Let's see. Let's make a note here in the comment to say how we're going to calculate this. So Unity has a, no, I'm not going to mention that yet. We'll get to that. All right, so int, the size of the arrays. Okay, for a cube, we had 36. Now, for this, we are going to have the cubes in the x direction times the cubes in the y direction times the cubes in the z direction, however many cubes the user specified. And for each cube, there are 36 array items that are needed. All right, so that should give us how many vertices we need in total. Now there's a squiggly here because cubes is a vector 3, which is floats, and this is an int. So that's easy. We'll just typecast this as an int. And to understand what's happening here with these cubes, let me kind of just comment it out that, all right, or let me put it up here so it's easier to read. So a triangle had three vertices, and a quad, which is made up of two triangles, has 6 vertices to describe it. And a cube, which has 6 sides, or 6 quads, 6 times 6 has 36, and that's where I get the number 36. All right, there, that way we can remember when we look at this next year, and we forgot what we were doing. All right, so now to allocate the arrays. The vertices array is going to equal a new vector 3 of size, and the triangles array is going to equal a new int of size. And then the UV array is going to equal a new vector 2 of size. Whoop-de-doo. All right, so that's the only difference. We have to wait to see what's going to, oops, I said vector 3. A new vector 2 of size. So that's one difference. We have to wait because we're going to see how big they want the cube to be. Let me just throw that on the chunk mesh thing so we could get our cube number here. So here's a chunk mesh. Let me just throw our script that we're creating right there. And okay, it still wants material. Yeah. And here's the cube size. So, you know, let's start off easy. Well, a smallish chunk, 333, and that'll test cubes being built in each direction. Okay, so we'll start off with a small chunk of 333. And let me do a save. And there, that way when the code runs, we can allocate that. All right, now we can go on with the, well, we always know that the get mesh and set mesh, they've been the same through the triangle, the quad, and the cube. And guess what? They're still going to be the same now because basically get mesh and set mesh, their job is really, it's just to, you know, set the data that we've defined. So they could stay the same. So I'll put them down here, boom. And we could have those functions taken care of. I explained them in the other videos. They remain the same. And now define mesh data. That's the doozy. So we're going to define a whole chunk of cubes. So private void define mesh data. All right. Now we already know that, let's see. Well, we're going to want the code that defined a cube. So here in the cube mesh, when we define mesh data, we just loop through and define the 6 sides. So let's copy that part in here. Boom. And it looped through the enumeration to get each enum code, and then it passed to a define quad function to make that side, and that's going to be the same. See, so everything we've been working on in these videos, it just builds up on each other. It builds up. Okay. All right, so that's a thing. Now the only new thing here is that we're gonna have to make a cube at different offsets from this first spot, and this little thing on the floor thing that we're putting here, this is like a guide. So the first cube is going to start here and just cover over like this space, but then as it goes into X, it should make another cube here, offset from here to make a cube, and then the third cube offset from here to make a cube over there. All right, so each of these cubes is going to make, they're going to be offsets of this origin point of our chunk mesh empty game object. So the define quad is going to have to take some offset values instead of just taking the code. So we're going to have to update it to take a vertice offset in our array. So let's just make a, let's see, we're going to have like an integer v that's going to be our vertice offset, and then we're going to have a vector 3 p that's going to be our position offset, and then we could pass those to the define quads, v and p. And we're going to have to be looping through the z, y, and x axes. So I guess we could have 3 for loops. All right, so to make our chunk, we're going to have 3 for loops. In the outermost, we'll just do the z. Z equals 0 until z is, as long as z is less than cubes, dot z, z plus plus, and come on, adjust yourself. There. So it's going to be 1, and then the next we'll have to go through all of the y's. Int y equals 0 to y is less than cubes dot y plus plus. Boom. And then the innermost loop for int x equals 0 to x is less than cubes dot x plus plus. So this is the thing, all right? That means this here where we make a cube, we're going to have to put this inside of there. So let's put this inside that loop so it makes a cube at each of those positions. So remember, our data, our arrays, they are going to be big enough to make all these cubes, but we have to know where do we start? What's the offset in our arrays to make this current cube here? All right, so this is going to be make a cube at offset. So for v, we have to calculate an offset. So let's think. So for the x, that's the innermost one, so that's just x. Then we're going to have to add for the y's. It's going to be, let me move that out of the way, y. I think now I could like take away this double window. So for the y's, it's going to be y times the cube's x. Okay, because we have to have a whole full row of x's before we go up and do the next row of y. So then we multiply by cubes x. Then we're going to have to add for our offset the z, and z is going to be the cubes x times the cubes y. All right, and that is for the same reason. So here you have the x's, and then for each y, you're going to have 3 x's, right? Now for each z that you go backward, you're going to have 3 x's and 3 y's. So that's how come I'm multiplying by that. Now there's a squiggly line. There's a squiggly line because, once again, the cubes thing is a vector 3, which is floats. So let's typecast it to int. All right, and this is vertice indexes. So here, these are just cubes, but for each cube, we have 36 vertices. So we are also going to have to multiply that whole result times 36 to get to the right vertex offset in our arrays. So this should be our offset for the arrays. Now we have to have an offset for the position that we start generating the cube at. So for that, let's think. This one is kind of easy. It's just going to equal a new vector 3 at x, y, and z. That one is easy, right? So now we have our 2 offsets, and our defined quad, we're going to have to pass it the offsets to build the cube balls at. So let's see. So we're going to have to pass it the int v, and we're going to have to pass it the, what's going on here? The vector 3p, the vertice offset and the position offset. Now I did make these variables just 1-letter variables. They're not very descriptive, but that is because now here in define quad, I'm going to actually have to, change the define quad to add for the vertices. So if this was the first cube, it would just be 0. But we have to consider the vertex offset. So all of these are going to have to change to v plus whatever. Okay, all of these vertex indexes. So I could try to do this a little bit easier with some search and replacing. So let's see if that works here. If I do some search replacing, so it's going to be everywhere I'm in this define quad method. Let me try to use search and replace. So I will say replace in files. And it's not really all the files. I just want to look at the current document. And I want to look in the current block, which is this function. The current block is from this bracket to the closing bracket of this method. All right, so let's see what we're going to look for. Let's look for everywhere there's a straight bracket. And we will try to replace what a straight bracket shows to a straight bracket v plus space. Okay, check this out. Check how this works. So first I'll find next, and it's finding this first one here. And here, yep, I want to, hey, where's the replace? Oh, here we go. I got to click replace in files, just make sure everything's good. And this one I want to replace and then go to the next one. See, so it replaced it for me. I have to type it. And this one, this one, this one, this one, this one. So I just say replace next on all the ones that are true. The same thing for here. All these indices are going to have to add the v. So this one, 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 this one. And I'll just continue. But I'm going to go saying replace next for each one. I just want to make sure it doesn't replace anything by accident. And then I'll have to spend like an hour looking for that mistake in the code So I'm going one at a time, just making sure it's getting what I want. Okay, then I'm adding the vertex offset, the array offset here. V, 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 V. Everywhere that's mentioning an indice into an array, I just have to add V. Now think, after I finish this, did I actually get them all? Did I actually get them all? Because look here, the vertices here, this is going to be V plus 0, right? And the triangles are supposed to refer to the vertices to say which point the triangles go from. So if this is V plus 0, but this still is 0, it's not going to point to the right vertice. So I also have to add V on these numbers here. So let's see if I could make a replace statement that works with that. So they all have equal. So I'll try the equal space. Let's see. And then I'll change it to equal space V plus space. Let's see how that one works. So we'll find the first one. And it skipped. Let me go up here and click the mouse up here. And let me see, find. Yeah, it's finding that. That's not a number. Find next, find next, find next. Here's one. Replace, 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 replace. Yeah, this one you got to take it slow. Next, 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 next. Next, 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 next. Replace, 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 replace. Next, 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 next. Next, 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 next. How fast could you say next? And these are going to be replace, 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 replace. Next, 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 next. Next, 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 next. Next, and keep going. Na 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 na. Bing bong, bing bong, boom bong. And then na 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 na. How many more do I have to go? Is this the last one? Na 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 na. Bing bong, boom bong, bing bong. All right, so now we're talking about the right array positions. All right, so what's the other thing is the positions our points are. They have to be at the right offsets, right? So right now, all the point A, B, A, D, C, B, that's all referring to the first cube. So we're going to have to add the offset here. This one should be a little bit easier for search and replace. So here I am. Let me do it again. Edit, find and replace in the files. We're going to look for equals point dot, and we're going to change it to equals P plus point dot. Okay, and that will add our offset for the position of the cube. All right, let's try it. Let's go for it. Let's say find next, replace. That looks good. And this one should be pretty straightforward. Bing, bang, boom, bang, boom, boom, bang. Bing, bang, 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 boom. Bing, bing, bang, bang, boom, boom. Bing, bing, bang, 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 boom. You got to say bing, bing, bang, bang, boom, okay? Bing, 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 bang, bang, boom. And there we go. So now we've updated our define quad to define a quad on the right offset in the array and the right offset in position. And we pass those in. And here we calculate the offset for the array and the offset in position before we pass it in to define a quad. And I think that at this point, these are the changes enough to have everything work. Whew. So let me take a look real fast. Yeah, everything's looking good. Let me just shrink up the code, collapse the definitions. Everything looks good. All right, let's see if it works. All right, so here, make sure we saved it. And now let's go to here and check our chunk mesh here. It has a script, we have the material, and we're going to do 333. So let me press play and cross my fingers. Ah, thank goodness it works. All right, so it's working. And if I wanted to, I could just do 311, and this will make 3 in a row in the X. You see? Boom. Or I could do 3 in a row on the Y. 3. Boom. Or I could do 3 in a row on a Z. Boom. But how big can I get a chunk? Let's try 10, 10, and 10. So that's 10 times 10 times 10. What is that? 1,000? All right, so let me press play. And let's see if we could do 1,000. And let me look in the scene view so I can look around here. Yep, it looks like it completely made the chunk. Okay, that's good. All right, let's try bigger. Let's try 20, 20, and 20. Press play. And something doesn't look right. Yeah, it's not a whole full chunk. It looks like it just ran out. Now, why is it running out? It's running out because by default, like a mesh filter, the size of the array in a mesh, it's only an int 16, which is, how many things is int 16? Let me see. So now here where we're allocating our arrays, it wasn't able to allocate the full size. So let me just put a note here about this, because yeah, everything in memory there is the largest amount that you can allocate. So Unity has a max vertices per mesh that it can do. All right, but there's two modes to this max. There is the 16-bit mode, okay, which its max vertices equals 6, 5, 5, 3, 5. This is like a binary thing. But then if we switch the mesh to 32-bit mode, then our max vertices is actually 4 billion. 1, 2, 3, 1, 2, 3, 1, 2, 3. So we could have many more vertices if we switch our mesh to 32-bit mode instead of 16-bit mode. But how do you do that? How do you switch our mesh to 32-bit mode? So let's look here in our get mesh, and right here before we return the mesh and get mesh, let's see what M has. The mesh object dot. Let's see if it has something for this. Let's see if it has an index format or something. Dot index. Oh, there it is. Index format. Format of the mesh index buffer data. Okay, so we can make sure that we're in 32-bit mode. Equals rendering index format. Okay, there's an enum for it. Dot, and you see here 16 and 32. So if we switch it to 32, now we should be able to get a bigger mesh, because 4 billion is way bigger. All right, so let's see now. So the 2020, let's see now if that renders out. And it looks like it did. We got a 2020 size cube. All right, chunk, I should say. We got a 2020 size chunk. There's 20 in each direction. Ooh, let me go bigger. So, 4 billion is a big number. So let me try 100, 100, 100, and hope my computer doesn't choke, and press play. If it chokes, the video is going to get all messed up. Press play. And it looks like it's working a little bit harder this time. Ooh, it's busy. It's busy. Yep, we have no optimization here. We are just drawing every single face of every single cube. That's 100 times 100 times 100. How big is that? Let's see. 100 times 100 times 100. It's 1 million cubes that it's making for this chunk. Yeah, so it's going into the time zone here. All right, that took 43 seconds, and there's 100 cubes in each direction. All right, and yeah, my Unity is chunking up for this. So next thing we're gonna have to do is we're gonna have to optimize. We're gonna have to think a little bit smarter about drawing every single cube and every single face. So that'll be next video. Goodbye. You made it to the end of the video. I'm so proud of you. This is my website. The main thing I want to show you is that for any of these videos that you've seen on YouTube, I have the tutorial section, which has the blue links for the projects, and the orange links are the files. Also, you could go over here and play some of the games we made in the game camp.